Hi guys, my name is Trevor Day. I'm in Dr. Markham's ISE 301 class here at Michigan State University, and today I'm just going to talk to you about how matter can change. So it's something we've been discussing in class for the last couple of weeks. There's two main ways matter can change. It can change through a physical or a chemical change. So just a few quick things about matter that are important to understand is that it can be changed physically, mentally, but it's limited to just changing. It cannot be destroyed because the atoms which make up matter are forever. So when the matter and the energy interact during these changes, the atoms and the energy units are both forever. Neither can be destroyed. So now we'll just move to our first type of change, which is the physical change. The physical change is when the substance will remain the same. So there is no change in substance because of the two interacting. The substance is going to stay the same. It's going to be composed of the same exact atom groups. So it's also important to understand that it will take less energy for a physical change to occur than a chemical change. So chemical changes will require more energy, and those energy units in both cases will not be destroyed. They'll still have the same amount of energy units, perhaps just in different forms. So the first example I'll show you today is just a chart from the molecule scale. So here you can see we have, as I model this, you can pretend these scales are together too. So pretend it's butter. So we got 3 different molecules here, 3 different molecules here. The total weight of all of them is 17 grams. So as we move to a different state, they're all in different locations spread out, but they're the same exact molecule still. So they were never separated or moved, they just bounced around, they changed location, ended up in different areas. And now you can see the weight is 17 grams, which is the same. So the mass stays the same for both these interactions, which is another important thing to understand. Okay. So the next part of the physical change section of this video I'll discuss is an investigation we carried out where we just held a little bit of butter in our hand and saw what would happen as our thermal energy from our hand heated the butter, if it would change it to a different state of matter or if it would stay the same. So as we did this, I can show you pictures I took during it. So you can see here, that's the butter in a solid form. So those molecules within it are just kind of vibrating right now. It's a solid from the human scale. You can see it's just butter. So, and then as I held it in my hand, it slowly began to melt into a liquid form. So as you can see here, you can see the glare, you can see the moisture. Quickly became a liquid, even more so after this picture was taken. But you can get the idea there. So that's the before picture and the after picture. So as this change occurred, the butter melted again because of the thermal energy from my hand being transferred to the butter, which made it change its state from a solid to a liquid. So to analyze that a little further, the thermal energy being transferred caused the molecules to move faster, making them go from a vibrating state in the solid to a sliding state in the liquid as they sped up. And then from the human scale, again, it just looks like wet, almost same idea as if you were to put butter in the microwave to warm it up for the popcorn. So same thing occurs there. So now I'm going to move to the chemical change. So during the chemical change, the composition of the molecules change. Again, the molecules will remain the same forever, or at least the atoms will remain the same forever. The molecules might get bounced around and switched a little bit. So some examples of the composition changing is an apple. When you cut an apple and leave it out for a little bit, it turns brown. So that's a simple chemical change of the gas affecting the solid and chemically changing it to a different color. Or if you burn a piece of toast and the toast appears to be black. So that's another example of a chemical change. So the experiment we did for this one, so up to the order and show you the experiment first. We did an investigation where we stained a piece of cloth, two different stains, 3 of them, and then we used OxiClean to try to remove the stain on one of them. I chose a Tide pen for my second stain removal, and then we just left the third stain alone. And we did that for both stains, all 3. So I can show you a picture of what that looked like. So this is going to be the before picture. The very bottom left is going to be where the Tide pen was placed after this picture. The middle is going to be where the OxiClean was placed after this picture. And the third we just left in its natural state with no cleaner on it. On the left side we have ravioli sauce, and on the right side we have Mountain Dew, which appeared much more yellow after it dried. So this is the before picture. If we go to the after picture, you can see a little bit of difference. It's kind of hard to see here, but with the Mountain Dew, the OxiClean was by far the most effective, almost turning the cloth back to white. OxiClean was the second most effective, and then right there is where we did nothing. You can see it's much more yellow than the other 2. With the ravioli, there was a lot less of a difference. You can obviously tell which one we did nothing to, being top left. In the middle, I was surprised that the OxiClean didn't do more to remove the stain from the ravioli, and was actually shocked that the Tide pen did a lot more. My guess for that is that the Tide pen scraped. The OxiClean you could just kind of pour down, but the Tide pen you had to kind of scrape against the cloth, so that kind of removed a lot of it as it on the spot, which could have been a flaw in the experiment. But that's what that looked like. So I'll turn it back to me. And just to analyze that a little bit further, so the OxiClean destroyed the stain, but the Tide pen obviously worked better for the ravioli. The OxiClean destroyed the stain for the Mountain Dew. So the Tide pen worked better for the ravioli. This reaction happened so molecules in the stain were broken up and the composition was changed. So the molecules were mixed up, put in different spots, and then that removed a lot of the stain. From the human scales, the stain lightened after the cleaner was applied and left for a while. You could kind of see more of an instant reaction from the Tide pen compared to the OxiClean. But yeah. I can kind of show you that from a molecule scale as well. So if you look here, this is a chemical scale. It's the same idea. This is going to be baking soda and vinegar, just to give you a different example. But as you can see here, we have it weighing 5 grams is the baking soda. So there's the molecule in its full form. And then this is the vinegar molecule in its full form, weighing 15 grams. Just numbers I made up. And then as they interact, you can see the change. It's formed new molecules, no particular ones, but they're connected differently, the atoms are, into new molecules, which is something we didn't see in the physical change. The total being the same still, 5 plus 15 equals 20. So you can see the molecules are different, but the atoms are all the same. So there's still the same amount of carbon, still the same amount of hydrogen. They're just in different places, kind of all over. So yeah, there's one more thing I just wanted to show you today. It's the before and after of the energy units, which are remaining the same forever. So we're going to go back to the energy units for the baking soda and vinegar, just so we relate it close to the example I just showed you. So here you can see the baking soda consisted of 7 energy units. The vinegar consisted of 5 energy units. This is the before. If you look at the after, if you add those up, adds up to 12, 7 plus 5. If you add these up, 4, 7, plus 5, 12 again. They're just kind of in different, just kind of spread out differently. So as you can see, they were broken up. They formed a H2O, or in the form of H2O, in the form of CO2, and in the form of that molecule. But that's just about all for today. I hope you have a better understanding of the physical and chemical changes that occur, some of the properties from the human and molecule scales that you can put together now. And yeah, so enjoyed learning more about it. I thought this was a good learning experience, and I'm sure I'll talk to you again.